In this section here, this video, we're going to move away from graphing and go back to linear equations in one variable. Basically solving linear equations in one variable. Now this is something you're probably all familiar with, but we're going to talk about it. Before we get to it here, there are three types of equations we can look at in one variable. There's what's called an identity equation. There is a conditional equation. And then there is a contradiction. Now, these three types of equations here that we can have, most of the time we don't necessarily know which one we have of these three cases until we start solving the equation. A conditional one is the one you're probably most familiar with, even though you might not have heard the term. This is when we have specific values and I'll say a finite number for the variable. And that means like you might get x is equal to 5 or x is equal to -3. Now, the equation might have more than one value for x. Maybe you could get x is equal to 4 or x equals 5. You know, there's lots of options for a conditional equation, but the key here is that there's specific values and there's a finite number of them. Now, an identity means that the equation is basically equal to itself. This is where we have infinite solutions. There's an infinite number of answers. And we'll give an example of that here on how you can determine that when solving these. And a contradiction is when we have no solution. The equation itself contradicts, it's not possible. And we'll look at an example of that as well. So now to solve these equations, we're going to use properties. I'm not going to write them up here. These are things that you're probably familiar with. The idea that you can add a number to both sides and it doesn't change anything. You can multiply or divide by a non-zero number. It's important you never multiply or divide by 0 when you're solving an equation, because you essentially, well, first off, you can't divide by 0. Second off, if you multiply by 0, you're just getting rid of everything. So let's look at some examples here and then determine what kind of equation they are, and then whether or not they have solutions. So let's look at the first example here. So I'm not going to write the directions down. Each of these examples is going to be the same. We're going to solve it and then determine if it's conditional, contradiction, or identity. So I have 2 quantity x minus 1 equals 2x minus 2. Now we're going to go ahead and solve this, and this is going to kind of get us into how we can determine if we have identity or contradiction. So if we solve this, the first thing is, of course, we'd want to multiply everything out, use the distributive property. So you have 2x minus 2, and then this is equal to 2x minus 2. Now, right away we can see that this is an identity. Why is it an identity? Well, I've got the same thing on the left and right hand side. So I know it's an identity, so I know it has an infinite number of solutions. In other words, x can be any number, and it's going to be a solution to this equation. But how would we do this if we were actually trying to solve it? Well, let's go ahead and maybe do the whole add 2 to both sides. And so you'd have 2x equals 2x. Oh, and then we try and get the variable on one side, so let's subtract 2x from both sides. And we get 0 equals 0. So the key thing here, and I'm going to emphasize this, the key thing here is for an identity, the variable, I'll say, goes away. I mean, it goes away because we subtracted 2x from both sides, and we're left with a true statement. Now what do I mean by a true statement here? Well, 0 equals 0. Is that true? Yes, this is true. Okay, so what this means is, again, my equation here, this is an identity, which means I also have infinite solutions. But really what we want to think about this is the solutions here, because we're talking about one variable here. The solutions are all real numbers. So you can put in any number into this original equation and you'll get that both sides equal each other. Okay, so let's look at another example here. Let's look at a fairly straightforward one as well here. So let's look at 3x minus 5 equals 2x plus 7. Alright, so we're going to solve this here. Now you could solve this however you want to. I'm going to go ahead and still do the add 5 to both sides. And so I get 3x is equal to 2x plus 12. And then I'll go ahead and subtract 2x from both sides. And of course, if I subtract 2x from both sides, you wind up with 3x minus 2x, which is x equals 12. So now we have to decide, is this identity, conditional, or contradiction? Well, if we think about the definitions again, when we have a specific value for our variable, in this case we have x is equal to 12, this is a conditional equation. So this is conditional equation. And the solution is x equals 12. Alright, so let's go ahead and move on to some more complicated examples. I don't think there's going to be anything that's too difficult here, but let's go ahead and look at, for instance, 3x over 8 minus 4x over 3 equals 4. Now, sometimes when people see equations like this, they see fractions and they're like, oh my gosh, fractions, this is going to be hard. Well, you can deal with the fractions, try and find common denominators and move the fractions together. But instead, what I like to do is I like to think about here, well, let's look at what a common denominator here. And you could find the least common denominator. You don't have to find the least common denominator. It's easy to see in this case, but you really just need a common denominator. So if you just take your denominator and say, oh, well, look, 8 times 3 is 24, and then let's go ahead and multiply both sides of the equation by 24. And if we multiply both sides of the equation by 24, well, I'll go ahead and take it in a couple steps here. You'd have 3x over 8, and then of course remind you, I'm not going to do this every time, but 24 would be 24 over 1 minus 4x over 3 times 24 over 1, and then of course we can just do 4 times 24, which 4 times 24 is 96. Now, what we see here is this 8 and this 24, we can do cross cancellation, so I'd have 1 here and then a 3, and then I can do the same thing here. This would be a 3 would go to a 1, and this 24 would go to an 8. And so we'd wind up with 3x times 3x, which is 9x, minus 4x times 8, which is 32x, and this is equal to 96. Okay, well then we do 9 minus 32, which is negative 23. X equals 96. And then we would get x is equal to 96 over negative 23, which we could just write as x equals negative 96 over 23. Now we should look at reducing this if we can. I know it doesn't reduce. The reason I know is 23 is a prime number, so there's nothing that can be divided into that. And if you do 96 divided by 23, you get a decimal number as an answer. But we would prefer you leaving them as improper fractions. Okay, let's look at some others here. So this is an example of another conditional equation. Now let's look at this here. So we're going to have 15, let me make sure I got a pen attached here, 15 over x minus 4 equals 6 over x plus 3. Okay, so we're going to look at this equation right now. Now, we're going to solve this one, but we have to look at this. This is still got one variable in it, but my variable is in the denominator. So before we do anything here, we want to write down what the solution is not allowed to be, because this is my original equation here, so it's got to work in this equation. Well, I know I can't divide by 0, so that means x can't be 0. But x can be any other number. So I write that x can't be 0 so that when I solve that, if I got my answer as x equals 0, I know that's wrong because the original equation can't have that, and so I would have no solution in that case. Well, let's go ahead and do the same thing we did in the previous problem, which is clear out the fractions. Now in this case I have an x in both of these. I don't need to multiply by x squared. In fact, that's a bad thing to do. You'd multiply just by x because that would cancel, get rid of all of our fractions. So I'd have 15 over x minus 4, and I'm going to multiply that by x. And then on the right hand side I have 6 over x plus 3, and since I multiplied by x on the left hand side the equation, I have to do it on the right hand side as well. Now I'm going to distribute it. I'm not going to show the work like I did in the previous one. 15 over x times x is 15 minus 4x is equal to 6 plus 3x. Now I just go through and solve this. So I would go ahead and subtract 6 from both sides. Now you'll see I won't always write the minus 6. I'm just going to say I'm subtracting 6 from both sides. 15 minus 6 is 9. So I have 9 minus 4x is equal to 3x. And then we'd add 4x to both sides. So you get 9 is equal to 7x. Dividing both sides by 7, x is equal to 9 over 7. Now it's okay to show your work like this. If you don't like the fact that I didn't write the minus 6 on both sides and you prefer doing that, that's fine. But you don't have to write the minus 6 on both sides. Alright, let's look at one more example here to wrap this section up here. So the last one we will look at here is going to be 2 over x minus 4 times x minus 2, and this is going to equal 1 over x minus 4 plus 2 over x minus 2. Now, we look at this problem here, and we have to ask ourselves, what are the values that x can't be? So if I look at this one here, I can't have 0 in the denominator. Well, if x minus 4 is in the denominator, that means x can't be 4, because 4 minus 4 would be 0. And then also, I have x minus 2, so x can't be 2. And if I look on the ones on the right hand side, that's the same thing. Now I have to think about what is the least common denominator I want to multiply it by. And well, if I look on the left hand side here, I've got x minus 4 times x minus 2, and then I have just x minus 4 and then just x minus 2. So I'm going to have my least common denominator is x minus 4 times x minus 2. And I'm going to multiply everything through by that. So I'd have 2 over x minus 4 times x minus 2. And then this is going to get multiplied by x minus 4 times x minus 2. And then this is equal to 1 over x minus 4 plus 2 over x minus 2. Whoa, what did I do there? Sorry about that. 2 over x minus 2. And then that's going to be multiplied by x minus 4, x minus 2. All right, well, let's see here. Well, the left-hand side is pretty straightforward because I have this x minus 4 here would cancel with this x minus 4, this x minus 2 would cancel with this x minus 2, and I would have just 2. Now, I will take this right-hand side in 2 steps here, because if I distribute that, you'd have 1 over x minus 4 times x minus 4 times x minus 2 plus 2 over x minus 2 times x minus 4 times x minus 2. Sorry about that. My hand keeps hitting the screen and moving it around. Alright, so then if we do a similar kind of canceling here, the x minus 4s would reduce, and these x minus 2s would reduce. So we end up with 2 is equal to 1 times x minus 2 plus 2 times x minus 4. Now we just have to solve this. 2 equals x minus 2 plus 2x minus 4. So you have 2 is equal to 3x minus 6. Add 6 to both sides. 8 is equal to 3x. Oh, I have a mistake here. I was going too quickly. Let's back up here a second. Back up. I made a very easy mistake. Some of you may have already caught it. So at this step here, I was distributing. So I have 2 on the left-hand side, and this is equal to 1 times x, which is x, 1 times negative 2, which is minus 2. And then I have to distribute that 2 plus 2x. 2 times negative 4 is minus 8. And I forgot to multiply then by 2. Makes a big difference in your answer. So then we'd have 2 is equal to 3x minus 10. Add 10 to both sides. Alright, and to finish solving this, we would add 10 to both sides, of course. So you get 12 is equal to 3x. Divide both sides by 3, and you get 4 equals x. Now this is where sometimes people make a mistake. They're so excited they did all of this work, and they're like, yes, I got x equals 4, and that's my answer that I started to erase. So they get 4 equals x, and they're super excited. Oh, I got it done. But then remember, the very first step, we always specified what were the values that x couldn't be. X, because this is the original equation right here. So that number has to work in the original equation. And in the original equation, 4 is not allowed because 4 makes your denominator 0. So what does that mean here? That simply means that this has no solution. So we went through all that work to find that it has no solution. But it's very important to recognize that. So whenever you encounter a problem where you have x's in the denominator, you have to first identify what x can't be, and then once you get your solution, determine if that's okay based off of your very first step.